Okay, so we're gonna go over the properties of quadratic function in standard form. So this is quadratic function in standard form, ax²+bx+c. The shape of a quadratic function is like a letter U. There are two possibilities of quadratic function. It's either it's gonna open up, or the quadratic function could also open down. So these are the two possibilities. In the picture that we have here, we have quadratic, the shape of the graph is opening up. These are the parts that we need to remember. The first one here is the axis of symmetry. So the axis of symmetry divides the graph into two pieces. It goes through the middle. So in this picture that we have here, we can write the axis of symmetry here and at the same time here. So that's the axis of symmetry. We also have another part here we call this the y-intercept. The y-intercept is where the graph touches the y-axis. And this lowest portion of the graph, or the highest portion of the graph here, is called the vertex. So these are the parts of the quadratic function. So we're gonna go over the properties of quadratic function. We start with property number 1. Okay, so we have here the first property of quadratic function. First, if a is greater than 0, the graph of the quadratic function opens up and the vertex is the minimum. Well, if a is less than 0, the graph of the quadratic function opens down and the vertex is maximum. So let's have an example to better see how this works. So let's have this equation, or this function f of x is equal to negative x squared plus 3x minus 7. Let's determine the a, b, and c first. So our a here is the one next to the x squared, so that's a negative 1. Our b here is 3, and our c is negative 7. So pretty much it's like a, b, and c. It says here that if a is greater than 0, the graph opens up. Let's look at the a here. Our a is negative 1. So what does this value tell us? The graph opens up or down? Down. Because if it's less than 0, so if the number is negative, it opens down. So we can go ahead and say that the graph opens down. So once it opens down, we can go ahead and say that it has a maximum. Because if we draw the graph here, it opens down. So this is the shape of the graph. It has a maximum. Maximum is the highest point in the graph. Okay, so that's how we describe this equation here. I'd like you to describe the second function here. You write the a, b, and c, and then determine if the graph opens up or opens down, or whether it has a maximum or it has a minimum. So try this next one out. Okay, so let's go over the second example here. We're gonna determine the a, b, and c for this. So we are looking at a. So it's because it says if a is either greater than 0 or less than 0. So our a here is 3. That's greater than 0. So this one opens up. So we can go ahead and say the graph opens up. So if it opens up, it has a minimum. The reason for that is because if we have a graph that opens up, this is the minimum. So minimum is the lowest point of the graph. Now let's have the second property. Okay, so let's go over the second property here. First, if the absolute value of a is greater than 1, the graph of the quadratic function is vertically stretched, or it's narrower. Well, if the absolute value is greater than 0, so this is read as greater than, and this is read as less than. So if the absolute value of a is greater than 0, And if it's less than 1, then the graph of the quadratic function is vertically compressed or it's wider. Narrower means the graph is narrow like that. Well, we say wider, the graph opens up wider like this. So these are that's the difference between a narrow graph and a wider graph. So let's take this example here. Determine whether the given function below is vertically stretched or vertically compressed. So we will start by writing the a, b, and c first. So that's a, b, and c. Our a for the first one is -1/3. Our b is 3. Our c is -7. The one that we're looking at right now is our a. So we say the absolute value of a. When we say absolute value, what happens to the value? It's always what? Positive. Absolute value is always positive. Okay? Now, looking at this value, +1/3, what is this in decimal? So let's see what that is. 1 divided by 3 is 0.33. So the absolute value of a is 0.33. Again, we are looking at a. We're not looking at b right now. We are looking at a to determine if it's narrower or wider. So we're looking at a. And then since we wanted the absolute value means it's always positive. So it's 0.33. So should the graph be narrower or wider this function right here? Should it have a narrower graph or wider graph? It's going to be wider. Okay? Because the number falls between, this is, again, pretty much it should say from 0.1, approximately 0.1, all the way to approximately 0.9. So whenever it falls within this, 0.1 to 0.9, it's wider. So then we can go ahead and say that the graph of this function is wider. I'd like you to try the next, the second and the third function here. So determine should it be wider or narrower. Okay, so let's go over the second one here. Let's write the a, b, and c first. Again, we're looking at a. The absolute value of a means it's always positive. So the absolute value of a is +2. So is the absolute value greater than 1, or is it between 0.1 to 0.9? It's greater than 1. So what is this? The graph is narrower. So it's going to have a graph that looks like this. Again, wider, it opens up like widely. Let's have the third one here. Again, we're looking at a. We need to find the absolute value. Absolute value means we take the positive. That is +4/3. You can use a calculator to divide it. 4 divided by 3 is 1.33. +1.33. So is the graph wider or narrower? 1.33. The graph is narrower. Okay, we're gonna have property number 3 here. Okay, property number 3 states that the axis of symmetry of a quadratic function is a vertical line with an equation x equals -b/2a. So please remember that if we say axis of symmetry, so if we have here this graph, so if the graph opens up, the axis of symmetry breaks the graph into 2 pieces, left and right. So this is our axis of symmetry, the red line. If we have a graph that opens down, the axis of symmetry again breaks this graph into 2 pieces, left and right. So that's the axis of symmetry. So how do we know what is the equation of the axis of symmetry? So it's this one right here. It's always going to be a vertical line. Vertical means from up, down line. So the equation is x equals -b/2a. Let's determine the the equation of the axis of symmetry for this equation here. So first, we need to write down the a, b, and c. So our a here is -1. Others are wondering, like, where did you get the -1 from? There is an invisible 1 before the x squared. Our b here is +3. And our c is 8. Okay, we need to solve for the axis of symmetry. The equation is x equals -b over 2a. So let's put in the values. Put the value of b there, over 2 times, put in the value of a. So I will use red to plug in the numbers here. So our b is +3. And our a is -1. So what I did was I plugged in the b. I plugged in the a. Now I'm going to do the math to solve for the x here. So that would be x equals negative times 3 is -3. Over 2 times -1 is -2. Can we still reduce that? We can't. So this is already the answer. Now, what happens if both are negatives? When you divide two negatives, what's the answer? Positive. So it's going to be +3 over 2 is the equation of the vertical line. Okay? So that's how we got this number. So what I did, I just plugged it in. Try the second example right there. Solve for the equation of the axis of symmetry. Okay, so let's go over this example here. We're going to write down the a, b, and c first. We are going to solve for the equation of the axis of symmetry. Again, the axis of symmetry is this broken line here. It divides the graph into two pieces, left and right. So the equation is x equals -b over 2a. We plug it in. So this is the equation of the axis of symmetry. Again, the axis of symmetry, the one that we're solving, is the broken line. So that's the equation right there. Now let's have the fourth property. Okay, so let's go over property number 4 here. The property says that the vertex of a quadratic function is of the form. So this is the equation right here. Now, what is the vertex of a quadratic function? So if I have here this graph, the vertex is the point, the lowest point or the minimum, or it can also be the highest point. So this is our vertex. So these two here are the vertices of a quadratic function. So it's going to be the maximum or a minimum. Now, how do we determine what is the coordinate for this vertex? We're going to use this equation right here. So let's take the first example here. So we're going to write down the a, b, and c first, so that it's very important that we know what a, b, and c are, because we're going to plug it into the equation. So let's start with the a first on the first example. A is 2, our b is 12, our c is 16. Now let's solve for the vertex. So to do that, we're going to use this. So the equation that we have right there, so let's plug it in. So negative of b over 2 times a, comma, c. What's our c here? 16. So let's plug it in first. So that's a b, so that's 12. And our a is 2. And then we got a c, which is 16. Minus b squared over 4 times a. So again, our b squared is 12. And then our a is 2. So this comes out negative of 12 is negative 12. Over 2 times 2 is 4. And then we got a 16. Minus 12 squared means 12 times 12. So we can use calculator for that. 12 times 12 is 144. Over 4 times 2 is 8. So simplify further. We got 12 divided by 4 is negative 3. And then we got 16 minus 144 divided by 8 is 18. So that's going to be 18. What is 16 minus 18? Negative 2. Yeah? So it's going to be at negative 3, negative 2. So this is our vertex. I'd like you to try the second one here. We're going to go over this. Let's start with A, B, and C first. Then we go ahead and plug it into the equation. Make sure that you do the math right. Who got same answer as this? Okay, good. It's pretty straightforward. Now let's have the fifth property. Okay, property number 5 is pretty straightforward. The y-intercept of a quadratic function is of the form 0c. So let's define first what is a y-intercept. So if we have a graph, an x and y graph like this, and then we have a parabola in red, or if the graph of the quadratic function that looks like this. That's the x and y axis. It's right here. That's the x axis. That's the y axis. The y-intercept is where the graph touches the y-axis. Every quadratic function will always have a y-intercept every time, no matter what, and it's the form 0c. So y-intercept is where it touches the y-axis. So let's determine the y-intercept of the given function below. Let's have our A, B, and C first. So A, B, and C. Our A here is negative 1. The B is negative 7. The C is negative 3. What is our y-intercept? Our y-intercept is 0. And then just copy the C. So 0, negative 3 is the y-intercept. So it's pretty straightforward. Try the second one out on your own. Determine the y-intercept of the other equation. Okay, so let's go over the example here. Let's write down the A, B, and C first. Okay, now here's a catch. Others are thinking, look, it's missing. Nothing's in there. So what number is that? 0. So if it's nothing in there, that's a 0. Okay, so let's write down the y-intercept here. So the general form of the y-intercept of every quadratic function is 0c. So I write the 0 first. What is the c? 0. So it's gonna sit at 0, 0, or at the point of origin. So this graph crosses the point of origin at 0, 0. So that's the y-intercept.
This sums up the properties of quadratic function.